So after COVID-19, we're all pretty sick of pandemics and ready to just move on and think about something else. But we can't. We're not done yet. We haven't learned our lessons from the COVID-19 pandemic. We're still not ready for pandemics, and our pandemic risk is growing. So the next one could really happen at any moment, and it could be even worse than COVID-19. So today we're going to talk about our pandemic risk, but most importantly, how can we get ready? How can we prepare? How can we handle it better when it happens? Let's dig in. Welcome to the Human Survival Podcast, where we aim for world cooperation on critical threats to humanity. To survive, we must see ourselves first as citizens of the human race. To thrive, we must protect what is beautiful about humanity. This show is offered by the Human Survival Project, a grassroots movement for citizens around the world to push for a redesigned and much stronger United Nations. Our global threats need global cooperation. This is urgent, so let's start. Hi friends, welcome to the Human Survival Podcast. I'm Shelby Murtis. Thanks for joining us. So today we're going to talk pandemics. The Human Survival Project, this new organization that I'm a part of, we push for a much stronger United Nations that's capable of dealing with the global threats that we have. And we focus on the big existential threats that could make things fall apart on us if we don't manage them, including pandemics. We saw over COVID-19 how damaging a pandemic can be in terms of death and disruption and economic mayhem. But I'm carrying a concern that we'll have more pandemics in the future that could be even worse, or we have them regularly, or we'll have two at once, or, it could be crazy if we don't start to manage this. So that's what we're going to talk about today, and the goal is not to just scare you into helplessness. We're going to talk a lot of solutions here as well. And our fine guest is really qualified to talk about this, David Quammen. He's been an author and journalist for over 40 years, mostly writing about science and humans' relationship with the natural world, including pandemic disease. He's traveled the world extensively, getting up close with his subjects. He's a regular contributor to the New York Times, the New York Times Book Review, and National Geographic. He's written for many other publications too, including The New Yorker, Harper's, Outside, Esquire, The Atlantic, Powder, and Rolling Stone. He's also written 18 books. I will not list them here, but I'll mention a couple. In 2012, he released the book Spillover, which is about the risk of disease jumping from animals to humans. And he and the many experts he interviewed for that book warned us of the risk of pandemic long before COVID came. Unfortunately, the world didn't listen to that expertise fully enough. Then in 2022, he wrote about the COVID pandemic. That's called Breathless, the scientific race to defeat a deadly virus. And in that, he interviewed 95 of the world's leading scientists and public health experts to basically help us unpack what the heck happened here and how all that emerged in a pretty in-depth way. And then his most recent book is called The Heartbeat of the Wild. It's a collection of 21 of his stories that he's written for National Geographic over the years. He traveled to some of the wildest places on Earth and documented people working to study and protect nature. Yesterday, I started reading that book, The Heartbeat of the Wild. And in the opening, I was so moved by his writing. For one, it tapped into my constant sadness about what we're doing to nature, us humans. But also, he was so eloquent, and he really gets it. He understands deeply the beauty of nature and the importance of protecting it. So he's an excellent writer, and I really enjoyed it and look forward to reading more. And I encourage you to also. In the show notes with this episode, we'll put a link to his website so you can go check out his work. And I hope you will. So, David, welcome to the show.
Thank you very much, Shelby. It's great to be with you, and I very much appreciate that generous introduction.
Well
Look forward to
deserved.
talking with you.
Well deserved. So, we're going to talk solutions in a little bit, but I would first like to just do an overview of the risks that we face. I'm carrying this concern that we're up against more pandemics that could happen. And I'd like to just gauge from all the science you've learned, how big is this risk? And what are some of the drivers of the risk that we face?
Right. Well, the risk is huge and continuing and multifarious, and the drivers are many, but the elephant in the room, and I say this with apologies to elephants, is there are 8 billion of us humans on this planet. 8 billion hungry, smart, enterprising humans who are consuming resources. And our impact on the rest of the natural world on this planet is ultimately the product of population size multiplied by consumption, not just population size. And I always try and emphasize that. It's not just population size, it's how many of us there are consuming how much resources. And so the impact is coming to different degrees from different places. There are families living in villages in Africa that I have visited, families that might have 5 or 6 kids. Those families are consuming less than a middle-class family in the US with 2 kids. So when I say 8 billion humans is a starting point, I don't mean to be pointing at people, in marginal situations in low-income countries who may have more than the canonical, 1.9 children of the American family currently. I'm not pointing the finger there. I'm pointing the finger in the mirror at us who live in high-income countries and who consume a lot. But it's spread all over. The responsibility is spread all over. That's the beginning point of the conversation as far as I'm concerned. 8 billion humans consuming. And those two factors feed what I think of as the 3 big problems, that human-caused problems on this planet that we have. I sometimes call them the 3 rivers of woe. And those 3 problems are loss of biological diversity, the extinction crisis, climate change, and the threat of pandemic disease. And all 3 of those problems are ultimately caused, and they're running parallel to a great degree, and they're braiding into one another. And they're all being fed, these rivers of woe being fed by the melting of a great snowfield on a distant mountain. And that melting of that snowfield is caused by human population multiplied by consumption. So that's, you could cut away from me now and you would have from that the most important thing that I could say this afternoon.
Yeah, I get it. So can you describe for us how that overconsumption of nature and the climate change lead to pandemic disease? How does that risk our illness?
Yes, well, 70% of human infectious diseases come from non-human animals, come from our contact with non-human animals, come from our disruptive interactions with highly diverse ecosystems in which live many, many different kinds of non-human animals. And most of those diseases, some few of them come from or come by way of domesticated animals, livestock. Generally, the livestock are getting these disease pathogens from wildlife. So in most cases, if there are livestock that are transmitting these pathogens directly to humans, it's as intermediaries. We live in a world of, well, let's talk about I said pathogens. That means any of the little dangerous bugs of various sorts that can cause infectious disease in humans. That means viruses, bacteria, prions, a very special kind of disease agent that causes chronic wasting disease and Creutzfeldt-Jakob syndrome and mad cow disease. Those three, plus worms, fungi, and I'm forgetting something else.
Bacteria?
Certainly. I think I mentioned bacteria. Certainly
Okay.
bacteria, yeah.
Yeah.
But anyway, mostly of concern are bacteria and viruses passed to humans, and in particular in recent decades, viruses. So for short, we could talk mostly about the viruses that come from wild animals and get into humans. Those are what cause pandemic. Influenza viruses, coronaviruses, other kinds of viruses, retroviruses like HIV-1 group M, the pandemic strain of the AIDS virus. These viruses have their origination in wild animals. Everything comes from somewhere, and we are a relatively young species. We're about 200 or 300,000 years old. And so these viruses have longer histories than that, meaning they came to us from their other hosts, generally wild animals. How do they get into us? Well, these viruses don't seek us out. They tumble into us. They pass into us because of close disruptive interactions with the wild animals in which they are customarily live. So when we go into the wild, highly diverse ecosystems, tropical forests elsewhere, and we cut down the trees, and we capture and kill animals or ship them alive around the world, we establish timber camps, we establish mining camps, we expose ourselves to these viruses that the wild animals carry, and we give those viruses the opportunity to make a career change and shift themselves from infecting possibly an endangered species of bat or an endangered species of monkey or an endangered species of ape, such as the chimpanzee, and instead jump over, spill over, hence the title of my 2012 book, Spillover, into humans. And when they do that, they have made a great career move because, as I've been saying, there are 8 billion of us and more all the time. So if they establish themselves as human pathogens, human infecting viruses, then they have a vastly increased scope of habitat. And that's what the COVID virus, SARS-CoV-2, did in probably December of 2019, made that switch. And now that formerly obscure marginal virus is now one of the world's most successful viruses.
Well, and from what I understand, I think there's maybe two things happening at once where there's people going into areas of deep nature and they're bringing disease back out with them to the village that then hops on a plane and travels the world. But then you've also got this disruption, like say you clear cut a forest, you've got animals leaving that area and they end up in nearby villages where people are living, and there's like mixing that way also, right?
That's true. Yes, that's correct. And a third possibly a third category, um, people are capturing animals live and shipping them around the world, either for food or for traditional medicine or whatever. And that's another way that diseases get moved around and given the opportunity to spill into humans.
Yeah. Well, and then there's these wet markets that we've heard about where people are trading live animals and you bring, what, 20, 30, 40 types of animal together and mix them all, and it's just kind of a virus free-for-all.
That's right. That's right. And wet markets, we've heard that term. A wet market, for instance, in China, is what's generally meant by that is a market that carries fresh food. I mean, it offers fresh vegetables, fresh fruits often, but also livestock, fresh fish, sometimes kept live in these markets, um, domestic animals, domestic livestock being sold live to be butchered for food. Also, livestock or wild animals being sold for pets. A lot of birds, wild birds captured and being sold for pets, and wild animals, in many cases, also on sale live in these markets. And as you said, animals of one kind jumbled together and on top of in cages animals of various other kinds. So these markets can be great mixing bowls in which a virus from one animal might start out in a bat and through spreading of its excretions, feces and urine, and just breath might spread its virus to another kind of animal, a porcupine or a raccoon dog or a bamboo rat that's also there in a cage, and then that animal might spread it to humans. Great mixing bowl situations, very dangerous.
Yeah. Is domesticated meat production a concern? I mean, when you've got all these
Yes,
factory farmed animals in a pen trading disease with each other, is that a possible route to another pandemic?
yes, it is, and I'm glad you mentioned that, Shelby. I would have mentioned that before long, but absolutely. Industrial scale production of livestock is another um, another driver, another focus of risk. We now have, last I checked, we have about 33 billion chickens alive on this planet at any one time in recent years. 33 billion, 8 billion humans and 33 billion chickens. Yeah. Um, and most of those chickens are not in little backyard flocks or on little, family farm operations. Most of those chickens are in big industrial scale um, poultry um, operations. And we have a lot of pigs, a lot of hogs, also in industrial scale production, and of course a lot of beef, a lot of cows. The concentration of those animals makes them natural reservoirs and passing points also for disease microbes. And with the poultry in particular, chickens and turkeys, and to some extent geese and ducks, those big operations are petri dishes, for instance, for the continuing evolution of bird viruses that can become human viruses. And at the top of that list is the influenzas, including what's known as avian influenza, particularly high pathogenicity avian influenza, which is arguably the greatest ticking time bomb for us in terms of these diseases on the planet right now, avian influenza. So if you've got 33 billion chickens, most of them in large operations, you've got wild birds migrating, flying around the world, all influenzas, human infecting influenzas originate with wild aquatic birds, many of which migrate. They're carrying these viruses and they're stopping over in some cases in places where they can come down on the water and rest and feed places and in some of those places they're coming down into domestic poultry operations and sharing their viruses with the domestic birds. So there's this great passing of avian influenza from wild birds to domestic birds among domestic birds, and occasionally, as we've heard in recent years, into mammals. And one particular avian influenza, the one that's known as H5N1, that's its numerical letter code, uh, can be very lethal to humans. So far, does not transmit from human to human, but the more it has a chance to evolve in big poultry operations, occasionally spilling over into mammals, the more opportunities it gets to acquire mutations that might make it transmissible in humans.
Yeah. And one benefit of us humans being omnivores is that we have choices in what to eat and we don't actually have to eat meat.
Right.
Like we're not required to. This is a choice that we're making. So,
That's right.
you
That's
know,
right. We need protein, but meat is not the only form of protein. And mass-produced industrial scale livestock operations are not the only source even of meat. Although for many people, they're the only available, affordable source.
yeah, yeah. Um, One more risk that I'm concerned about is disease that could leak from labs where diseases are studied.
Mm-hmm.
I don't know if I want to go down the rabbit hole of whether COVID came from a lab, but we know that that risk is with us because over the years there have been many leaks of diseases from labs around the world. Not just
Yeah.
China, but in the US and in the UK that are documented, but in other places too. How worried should I be about this?
Well, whenever somebody asks the question, how worried should I be? My instinctive reaction is, um, don't be worried, just be informed and activated and aware. Don't lose sleep over these things, but when you're awake during the daytime, think about voicing an opinion and doing something about them. Um, you're absolutely right that there are dangerous pathogens that are being worked on in labs, that lab security is a great, important issue. There have been leaks of, of dangerous viruses from labs that have caused human illness, human death. There hasn't been one, as far as we know, that has caused a pandemic, um, but it's important. And you mentioned that rabbit hole in terms of the question of the origins of the COVID virus, SARS-CoV-2. I've been down that rabbit hole. I've spent plenty of time exploring the corridors of that rabbit hole, um, and uh, and I'm kind of tired of talking about it too. We need to know where this virus came from. I have studied that question, interviewed a lot of people. I wrote a long piece for the New York Times Magazine in last summer that appeared last summer, last July, on this subject. Um, and there has been a lot of argument about it. I'm not going to recap any of those arguments. Um, the story that the COVID pandemic might have begun as a live lab leak is a dramatic story and it attracts a lot of people. The evidence is not there. There is little or no actual empirical evidence to support that scenario. There's a lot of empirical evidence supporting the natural origins scenario, but there's no finality on that question at this point, and we do need finality. So we need to continue um, discussing it intelligently and calmly. Scientists need to keep working on it, and it may take a long time for us to solve that question with finality. Sometimes it does. When the Marburg virus first appeared in humans in 1967, it caused horrific illness and death. Marburg is closely related to Ebola. Everyone wanted to know where it had come from, what animal it had come from. And it took 41 years to answer that question. So the fact that we don't have an absolutely confirmed answer at this point is not unusual, and it doesn't lend credence to either to one side.
Yeah. I think the scientific exploration of where COVID originated, that's a good thing to do. But I've been really frustrated with the public conversation around it. I think looking into the lab leak, that has made sense. Go ahead and investigate. But what's frustrating is that it's so looking in the rearview mirror. And it seemed to me so oriented around who can we blame. And I want to be future oriented. And in all that conversation, I so rarely hear people talking about solutions. Like, for instance, okay, lab leaks are a risk. How can we make our labs safer? How can we put systems in place for that? Wet markets are a risk. How can we fix that? Spillover from nature is a risk. How can we fix that? And so often people have just been buried in the past, arguing instead of trying to fix these problems.
I agree with you, Shelby. And one aspect of that is that argument has become so heated that some of it has taken on the tenor of science versus non-science, belief in scientists versus disbelief in anything scientific experts say. And that's very, very damaging to the whole situation. Before we started recording, I mentioned to you that, and I suspect that you'll want to have gotten to this topic anyway. I mentioned that in terms of preparedness for pandemic, I think we are worse off than we were in 2019 before COVID. Not in all ways, but one of the ways in which we are worse off is that trust in science has suffered from a whole lot of confusing and confused argument and misinformation over the past 4 years. So we have been pushed backwards in terms of public confidence in science, and that's really a dangerous thing.
Yeah. Well, and that points to the importance of people like you who can communicate about this stuff with the public in a good, informative way. I mean, we need good, trustworthy sources of information more than ever, and people who can package it and explain it to the layperson. Because science is hard and it's complicated, and not everybody understands it.
Yeah, that's true. That's true. And there's a strong responsibility on those of us in my particular sort of ecological niche, the explainers of science, the intermediaries between scientists and the general public. It's a great responsibility on us to be very, very judicious, very accurate, very information-based, very careful, to avoid not just factual mistakes, but sensationalizing things in lurid ways that further scare the public or inflame the public. There is great pressure to do it right. And that's a little bit tricky because explaining science to the general public, you need to tell stories. You need to tell people stories about people, the people who do science. You need those stories to be compelling, dramatic, suspenseful, sometimes extremely poignant and horrifying, sometimes humorous. You need all those tools, all those storyteller tools, but you need to be absolutely devoted to factual accuracy at the same time.
Yeah. One very tricky thing about when COVID hit is that people were surprised and concerned, and there's fear, and everybody wants answers right away. And science is not a fast process, at least historically. I mean, we can now try to quicken the processes, but science is never, it was not designed for that give the public immediate answers that everyone craved, which then I think leaves everyone filling in the gaps with their own favorite conspiracy theory because they want to make sense of it.
Right. Yes, you said it's not a fast process, and I mentioned 41 years to solve the mystery of the reservoir host of Marburg virus. The Ebola virus, we still don't know for sure what the reservoir host, the animal in which it lives over long periods of time. We don't know the identity of that animal. But also, you said science is not a fast process, and that's a point that I want to reaffirm. Science is a process. That's one of the jobs of scientific explainers like me and my many colleagues. We need to help the public understand not just what science says. Science says that, this week science says that that eggs carry cholesterol and they may not be healthy for you in terms of heart disease. Next week, science says that eggs carry these certain chemicals that are extremely healthy for you, and stop worrying about it and eat eggs. Science changes. So what science says is not the point. What science is what we want people to understand. And what science is a process of incremental movement toward progressively more accurate understanding of the physical world. And it's a self-correcting process. Science makes mistakes and then corrects them. Science moves 2 steps forward and then sometimes 1 step back and then turns 45 degrees to the right and moves forward again. It's a human activity, a human process. Major League Baseball is a human activity. Grandmaster chess is a human activity. Science is a human activity. And therefore, sometimes it involves great discoveries and brilliance and courage. Sometimes it involves ambition, jealousy, competition. It's all those things. It's a fabulous story. It's an epic story of human effort and human foibles, which is what allows me to make a living, telling those stories, and also what challenges me to try and get it right and do it right in a responsible way. And again, likewise, all my colleagues in the world of science writing and science explaining.
Yeah, yeah. One way I'm worried that we might be worse off than before the COVID pandemic is that people may be more complacent than they should be now. So, for instance, as all this rolled around, the last pandemic of comparable size was the 1919 flu. And, people look back at that for comparison to learn how this stuff works. And so I heard people say so often, this is a once in a century pandemic, which could lead people to think that we've got another century before the next one happens. And like the next one could happen tomorrow because of all these risks that we started laying out. Our risk is greatly increasing, and we've just got a far different world than we had even a few decades ago.
That's right, absolutely. But remember too, Shelby, we had another pandemic that so far has killed 35 million, 37 million people, the AIDS pandemic.
Yeah.
A slow motion pandemic, very different from the influenza of 1918 to 1920, very different from COVID-19, but definitely a pandemic, still going on, but a slow moving pandemic rather than a sudden pandemic. Nonetheless, devastatingly lethal and disruptive.
Yeah, yeah.
But you're right that the next one, we have no. So say we've had 3 pandemics in the last 105 years. It doesn't mean that we can count on there being 34 or 35 years before we have another pandemic. It could start, as you said, tomorrow. And as I said, it could start with avian influenza.
Yeah.
Tomorrow.
Yeah. And correct me if I'm wrong, but my suspicion is that the future pandemic could be worse than COVID-19. COVID-19 is very transmissible. It's contagious. It spreads around quickly, but it is not as fatal as some other disease in terms of the percentage of people who die from it. So if we have another disease that is both transmissible and fatal, we've got a worse problem, right?
Absolutely. Absolutely right. This pandemic could have been so much worse. We've had what? I haven't checked the numbers recently, but I think maybe 700 million reported cases and 7 million deaths. Is that about where we are with COVID-19?
Yeah, I haven't
So
checked
that's,
the numbers recently, but it sounds about right.
yeah. Yeah. So 1 in 100, roughly 1 in 100 case fatality rate. I think that's right. The first SARS coronavirus, now known as SARS-1, the SARS that came out of southern China in 2003 and spread quickly around the world, killed 1 in 10 people, not 1 in 100 people. Another coronavirus that came out of a bat by way of some intermediate animals in wet markets or restaurants in southern China, the Pearl River Delta, upstream from Hong Kong. Spread around the world, it was transmissible on a cough or a sneeze, respiratory transmission, killed a lot of healthcare workers because at the beginning they didn't know what they were dealing with, and they were not protected adequately to deal with people who were admitted to hospitals having respiratory crises. You had 7 or 8 healthcare workers gathered around a guy who was having some sort of a respiratory crisis, and they're trying to get a tube down his throat, and they're not wearing masks because they didn't know. But only 8,000 people were infected. 800 died, 1 in 10. If you combined that virus with the COVID-19 virus, and you said, let's have a virus that's as transmissible as COVID-19, but as lethal as SARS-1, and in particular, a virus that is transmissible from people who don't yet show symptoms, silent transmission, undetected transmission. Put those things together with the case fatality rate of SARS-1, and that would just be much worse than even this disaster of COVID-19 has been for us.
Well, and we've got billions of people who now think they know pandemics because they've lived through one. And so, if another one comes, they'll be like, oh man, the government's making me wear a mask again and I gotta be on lockdown. And, they'll kind of resist the annoyance, not realizing this could be so much worse, like economic collapse, like massive death, like systems grind to a halt because people can't work, food shortage, like it could get really messy. And
yes, yeah.
I don't think people realize the risk,
No, I agree. There's a great danger in that, in the fact that, after a year or two of shutdowns and lost work days and schools closed and other severe inconveniences that really caused hardship to people. A year or two of that, and people had COVID fatigue, and they just said, "Oh, so just let it happen." If that COVID fatigue carries over, and we have another pandemic that starts, again, it could make things worse than COVID-19 has been. That said, let's say something positive.
Please, I'm ready. Let's do it. Let's fix it.
One thing we got right with COVID-19 is the vaccines. Scientists who developed first the mRNA vaccines, the 2 main mRNA vaccines developed in the West, the Pfizer vaccine and the Moderna vaccine, as they're commonly known, saved, I think it's safe to say, millions of lives, probably millions of lives. The Oxford AstraZeneca vaccine out of Britain, which is not an mRNA vaccine, but a different kind of vaccine, also has saved millions of lives around the world. And these vaccines were developed so fast. I tell the story in my book, Breathless. One of the threads of the narrative is how many days it took from the release of the first genome of that virus on essentially on January 10th, 2020, to the point where the first test doses of an mRNA vaccine were going into arms in the US. That was something like 61 days, I think. And then to the point when the first people, after the clinical trials, the first people in the general public were getting shots. That was 9 months, 9 or 10 months. Important vaccines had never been developed that quickly before. So we learned some things about how to develop vaccines quickly, and that knowledge is not going to go away. That knowledge is applicable to other viral threats coming in the future.
Yeah, definitely. So going forward, when we hit another pandemic, we want to do that well, get vaccination to everybody. One thing that was painful to see during COVID is that wealthy countries hogged up the supply at the beginning. And that to me seemed not only unfair from a moral perspective, but also just not good pandemic strategy. Because then you're letting a disease run rampant in poorer countries uncontrolled. Do we need a system in the world for managing this in a more sensible way?
I'd say we need hundreds of systems.
Yeah.
Yes, we need to make some improvements. You're right that the science and technology of producing mRNA vaccines and these other vaccines in a hurry, as I said, was a great success story. But vaccine equity was not a great success story with COVID-19. There was a severe failure to get these vaccines available to people in all countries, low income, middle income, high income countries. And that was not done very well for a variety of reasons that are above my pay grade, but that need to be worked on and fixed. And I can say a few things about some of those things. First of all, the capacity to develop and manufacture vaccines needs to be not concentrated in a few wealthy countries. It needs to exist in countries of all sorts. And how do we get that? Well, by supporting efforts to build capacity in low and middle income countries, training more molecular biologists, training more vaccine researchers, training more lab technicians, training more infectious disease doctors, training more epidemiologists, not just in Paris and New York and New Haven, Connecticut and Boston and London, but in Kinshasa, in Lagos, in Harare, in countries all over Africa and Asia. We need to be helping people develop the institutions that can train the smart kids that exist in those countries who have the capacity to be molecular biologists, to be vaccine researchers. We need to support those efforts so that the next time, as soon as possible, there are more than exist already institutions in those places, infectious disease research institutions, centers for disease control and prevention, universities teaching highly sophisticated molecular biology and epidemiology to the kids and the young people in those countries. That's not something that we in America can do. It's something that we need to be supportive of people in other countries and help them to do that, to create that capacity.
Yeah.
That's
we
really
have the funding, we have money here. We can provide that,
That's right. Yeah.
I mean, I think with this whole capacity you're describing, and really the whole public health system, it requires public money. So far, a lot of this is profit driven. These are for-profit companies researching and making the vaccines. But it's
Yeah.
hard to expect a for-profit company to ramp up with this capacity and then wait around 10 years not selling vaccines till the next pandemic. It's just not a
Right.
workable business model. And so you need public funding to smooth that out and keep those people employed and stock up on the ingredients and get ready with the vials and have enough needles, and like that requires public funding, you know.
Yes, absolutely. Yeah. And and private funding. It requires public-private partnerships. Um, and it's tricky, and again, above my pay grade of understanding that how to solve the problem of intellectual property rights for private companies that spend many, many millions of dollars developing vaccine technologies, drugs. How do they make their money back? Um, if if vaccines and drugs need to be essentially given away, um, public-private partnerships. I mean, I suppose that the answer is that they do need to make their money because otherwise they cease to exist, and they are important players, particularly on the manufacturing side of this. Um, and and we all need to pay. It can't just be the people in the villages in the Democratic Republic of the Congo who are being expected to pay hundreds of dollars for a vaccine. We all need to pay. We need to help with that. We need to flatten that disparity.
Yeah. And that's not just charity, that's self-preservation. That's how we fight disease. So, yeah. What are some other solutions we should be thinking about? What other types of preparations or systems should we be putting in place to be safer for next time?
Well, one thing that occurs to me is what's called, um, I think, proactive surveillance. Um, there are there are two main ways of dealing with viruses and other pathogens that spill over from mysterious sources from wild animals into humans. One is that when an outbreak occurs, when 200 people get sick in a village in southern Sudan or somewhere like that, um, medical teams, public health teams, disease doctors rush to that point and try and control that, try and contain that outbreak before it spreads and becomes an epidemic and then potentially a pandemic. That's sort of outbreak response. The other is surveillance, prediction and surveillance. Um, uh, the other big limb on the tree. And some people say, well, it's almost impossible to predict which virus is going to be the next pandemic virus. You can study viruses, you can gather viruses, collect viruses, you can categorize viruses, you can create libraries full of viruses, and you still won't know which one is going to be the most dangerous one. But there is also active surveillance that can be done so as to essentially to detect a dangerous virus that's knocking on the door of humanity before an outbreak occurs. At a point when a virus is maybe spilling over into just one human there and another human over here, and no transmission from human to human, almost indetectable by the old, outbreak response methods of detection. But if we're watching in the right way, we can see that virus is knocking at the door, or is there's a term for it that some scientists use, viral chatter. Viral chatter, viruses that are not yet spreading among humans, but seem to be investigating the possibility repeatedly. One human case here, one human case there. How do we detect those? Well, for instance, proactive testing of poultry workers and the families of poultry workers. People who work in those big operations where there might be, 400,000 chickens and 100,000 turkeys. Um, take blood samples from those people once a week, consensually, of course. Compensate them for the inconvenience of having their blood sampled once every so often, and then screened for influenzas, for unknown influenzas. Then you might see the next avian influenza knock at the door before it turns into um, a stampede through the gate. Mix metaphors a little bit, but you see what I'm trying to get at here. So that should be happening. That should be happening all over the world. These where animals are brought into wet markets, the people who are working as vendors in those wet markets, let's prick their fingers and get a blood sample from them and see if they're carrying any viruses that raise alarms. Likewise with poultry workers. Likewise with employees that work on big piggery operations. Let's screen them to see the level of risk that they're experiencing, because they're the front line.
Mm-hmm. Yeah, definitely. Do you think there's adequate capacity in most hospitals and doctors' offices and such to detect a new disease as patients come in? Are they watching for the right things and have the right tools?
Again, I don't want to try and sound like an expert in things that I'm not
That's fine.
that I'm not qualified to talk about. So, um, the medical profession, I'm sure they could do more, but I'm not the one to tell them you should have this further capacity in these doctors' offices, these hospitals. It's just not. I know a lot more of what can be learned through walking through the mud of a Congo forest than I know
Yeah.
about how to improve hospital management.
Yeah, that's fine. Well, actually, the mud of the Congo forest is where I was going to go next with this.
Good. I'm always happy to go there.
Well, modern hospitals and doctors' offices have some capacity to screen for disease, but a lot of the world does not have even basic health care. People don't get to go to doctors, there's no hospitals, and so in many places of the world, we're flying blind. So for instance, I read this article a few days ago about a supposed I think it's anthrax outbreak somewhere in Africa lately. And I'm getting the numbers wrong, I'm sure, but there's like 1,000 people who have showed up in various places with anthrax-like symptoms. But only 20 of them have been tested. And some of them tested positive and some of them tested negative. So there's people saying, well, because of those positive tests, that must all be anthrax. But we actually don't know if we don't have the testing capacity out there to figure out what's what. It seems to me that's the weakest link in this global, a global system of managing this. That's the weakest link when we just don't know what's going on out there.
That's true. That's true. And even at the extremes of luridness and drama, the Ebola virus, the infamous Ebola virus that kills up to 50% of the people that it infects and causes catastrophic loss of bodily fluids, vomiting and diarrhea, and in some cases bleeding. That's not so easy to diagnose at a clinic in the northeastern corner of the Democratic Republic of the Congo. If you're, a group of nursing sisters from from some religious order, or if you're a couple of doctors and physician's assistants working at a remote clinic, you don't have the capacity to say, well, this is definitely Ebola, and there are other diseases that can look like it. There are bacterial diarrheas, shigellosis, that is sometimes mistaken for Ebola and vice versa. But if it is Ebola, you want to know that as soon as possible and take the necessary measures to protect your patients and protect the community and protect yourselves. Um, so it's difficult. Yeah. Yeah.
Yeah. So it seems we need we need a very strong World Health Organization and, agencies like that to manage an international response, because we're seeing that disease can pop up anywhere in the world and spread everywhere, and we all got to work together. I don't know if this is in your expertise or not, but I'm wondering, what's the state of the WHO? Is it in good condition? Is it ready? Does it need more support, more funding?
It certainly needs more support, more funding. There are some terrific people at the World Health Organization on the scientific side and at the clinical side. I know some of them, but I'm no expert on by any means on the World Health Organization. The World Health Organization is a creature of the World Health Assembly. The World Health Assembly is a creature of the United Nations, as I understand it. And therefore, those are not just health organizations, but they are extensions of political bodies. And therefore, they suffer the constraints that other agencies and organizations and institutions that are fingers on the hand of bodies that are political bodies also suffer. We do need to support strengthening of the World Health Organization. I don't know how you do that specifically, given that you've got 190 some countries in the United Nations that have very different views as to how disease should be perceived and understood, let alone studied, controlled. You have national sovereignties that are at issue. The World Health Organization can't just say, we're coming into your country and closing the schools and taking over the hospitals. Can't do that. And probably shouldn't be able to do that. But it needs to be rigorous, strong, well supported, well respected, well staffed, and welcomed in countries around the world. And we're not there yet.
Well, I might, we would not want the World Health Organization coming into countries and dominating everything that happens, taking over schools and hospitals. But maybe we could negotiate a situation where WHO inspectors get to go in anywhere they need to study disease, right? Mm-hmm. They can stop by any hospital in the world and collect data, right? They can travel, they can investigate, they can monitor our virus labs, where labs are even cooking up new viruses, have the authority to monitor and set some rules on some of these things. Because if we just leave it to everybody to do what they want,
I think with the International Nuclear Regulatory Commission and inspectors, I don't know the specifics of that. I just have a vague sense that the kind of inspection powers you're talking about have at least sometimes in the past been available to international nuclear regulatory the International Nuclear Regulatory Body. I don't know that if that's still the case. I have just vague recollections of when it was a question of weapons of mass destruction in Iraq and inspections in Iran, that there was some power of the INRC to go into those places, but I don't know if that's still the case. Anyway, something along those lines, yes, it would be. I think it would be valuable.
Yeah, yeah. And, if I could wave my magic wand, we would back up this whole system with strong funding that's fair. Mm-hmm. All the countries of the world put their money in the pot. It's going to help us all. Everybody pay in fairly based on your economic strength. But, let this really be a shared thing because no country alone can handle the world public health system.
Yeah, yeah,
Everybody's got to pitch in.
absolutely. Yeah, yeah. Just a question of how you get there.
Yeah, well, lots of citizens demanding it.
Yeah,
So let's start.
yeah,
So,
yeah.
well,
And that is for people to hear about it, for people to talk about it, for people to think about that need that you're highlighting there. I agree.
yeah, yeah. I mean, it starts with conversations like this. I mean,
Yeah,
democracy is lots of conversations, basically. And so
yeah.
we need to all just talk it up and not, what do you call it? Not have low standards for ourselves. So a lot of
Or low
times
expectations.
people
Yeah,
people see these big issues and it's complicated and it's global and they're like, "Oh my god, it's too hard. We're never going to do that." But like
yeah,
that's the recipe for destruction. Like we don't have a choice, right? We just have to get this done. So
yeah,
let's quit griping and do the work. Let's talk it up and we'll get it done.
yeah,
So
yeah.
I don't know. That's my approach anyway.
Amen to that.
Yeah. Well, we've been having a good conversation and we've covered a lot. And I want to respect your time. But is there anything that we didn't share that you want to?
We covered a lot, as you say. I think the only thing I would like to do would be go back to that metaphor I mentioned at the beginning, the three rivers of woe, and to ask people to bear in mind all three of those. There's a tendency now for people, especially younger people, much younger than I am. I'm a geezer now, um, to have grown up with the concern over climate change, and that's a hugely important concern. It's a cataclysmic problem. But it's not a problem that encompasses all of our other problems. And some people are inclined to think that, oh, a loss of biological diversity, loss of species, well, that's caused by climate change, right? Um, Disease, pandemic, emerging pandemics, that's caused by climate change, right? Well, no, not everything is caused by climate change, but everything is related to climate change. These other two problems that I'm talking about, emerging pandemic threats and loss of biological diversity, are not encompassed within the basket of climate change. They are co-equal to it. They are distinct cataclysmic problems that, like those three rivers I keep talking about, run parallel to one another with climate change, all caused by snowmelt on that big snowfield or glacier on that mountain, and the melt being caused by human population times consumption. So I I'm repeating myself, I suppose, but I can't repeat that too often. Is that I really uh, I I cringe and I grieve whenever I am reminded of the fact that we are losing insects on this planet. There is something called the insect apocalypse that's happening. We are losing diversity and abundance of insects, as well as all other kinds of animals, plants, fungi, bacteria, biological diversity. Um, I grew up as a kid who cared deeply about insects, as well as all other kinds of animals that I ever came in contact with. Um, if we no longer see monarch butterflies migrating south in the fall across our baseball fields and our meadows, if the monarchs are gone, that's a tragedy as big as the loss of the passenger pigeon in the US. It's an incredibly abundant bird that was driven completely extinct during the 19th century by human activity. So I want people to keep all three of those in mind. The threat of pandemic disease, all these viruses that are not seeking us out but are finding us, all these creatures, these amazing creatures, lemurs of Madagascar and amphibians of the Andes and insects of North America, all these creatures where we're losing abundance and eventually diversity, whole species. I want people to care about that as much as they care about climate change and try and think about how we can solve those three problems together.
Yeah, I agree. Well, in saving those creatures, it's not just a matter of saving them, it's a matter of saving ourselves. Like
Yes,
it's a dangerous situation to let so many creatures go extinct.
yes. But we also need to care about saving them for their own
I know.
inherent
I
value.
know.
Because we
Yeah.
humans, we're what ecologists call a weedy species. We have great survival powers of adaptability. So if we come to a point where there's almost no biological diversity left on this planet, just German cockroaches and cabbage butterflies and the common crow, God bless the common crow, and a few other creatures and humans, um, that will be a tragic loss, even if we humans still have figured out a way to survive.
Yeah, I
But
agree.
we'll be living on a planet that's uglier, more boring, and more lonely than the planet that we inherited from our ancestors. And that would be a great tragedy, even if we humans survive.
Yeah, yeah. Oh, I'm right there with you. I love it also. And I might just encourage people next time you're thinking of buying that product you don't actually need, think about all the natural creatures that you love. Think about the trees. Think about the lakes and rivers as you're about to buy that thing you don't need. And maybe think
Yes.
about not buying it. Maybe that's an
Yes.
option, you know?
Yeah. Yeah.
So, well, David, thank you so much for this conversation and for
You're
being
very well, Shelby.
here.
Thank you.
I've learned so much. And dear listeners, I hope you've learned as much as me. I encourage you to go to David's website, check out his work, because it's amazing. We'll put a link to it down in the show notes. And before we go, I want to give a big thanks to Adam Rostan for his video and audio editing of this show, and to Alina Ko for her production support. And especially listeners, I want to thank you for being part of the journey. Thanks for being here. We'll talk to you soon.